Okay, you've got the second derivative defined by this rule. There was an x plus 1 in the denominator and x plus 1 in the numerator. They just cancel out. There's either a hole there or a vertical asymptote for the original function. So the second derivative equals 0 when x is -5 or when x is 6. So I'll put those numbers on a little number line. And I'm also going to put -1 on here because if the function is undefined at -1. So I indicate that with an X, and for emphasis, I drew a dashed vertical line here. Now, I'd probably never go to all this trouble to figure out the sign of the second derivative in each of these intervals, but this helps to visualize it. So for this interval here, from -infinity up to -5, pick a -10. -2 is always negative. This factor is negative raised to the 11th power is negative. -16 raised to the 7th is negative. So the product of three negative factors is negative. That means the second derivative is negative everywhere to the left of -5, which means the original curve is concave downward. And from -5 to -1, I chose a -3. You can see how these fill in. The product gives us a positive, so the second derivative is positive in this interval, which means smiley face, concave upward. Between -1 and 6, choose 0, positive, still concave up. But to the right of 6, like a 10, second derivative is negative, frown, concave downward. Okay, so since the concavity changes at this point right here, there's a point of inflection when x equals -5. We don't know what the y value is because we don't know what f is exactly. And concavity changed here, so there's a point of inflection at x equals 6. Okay, there you go. Hope that helped. If you have any questions, post a comment.